The next talk is given by Dr. Enrico SCALA. Professor SCALA is the head of the Clinical and Laboratory Molecular Allergy Unit at the IDI, which is part of the Scientific Institute for Research, Hospitalization, and Healthcare in Rome, Italy. So he's on a different time clock today, but we are so pleased that he could be here with us today. He's going to speak to us today about lipid transfer protein allergy, relevance outside the Mediterranean basin. Professor SCALA.
Okay, thank you very much for your so kind introduction, and thank you for the invitation at the American Academy of Allergy, Asthma and Immunology to talk about the relevance of lipid transfer protein allergy outside the Mediterranean area. These are my conflict of interest, and this is the list of topics I'm going to cover during my presentation. And starting with some information regarding lipid transfer protein as allergens. You know that lipid transfer protein have been discovered about 45 years ago and represent important airborne and food allergens, particularly spread in the Mediterranean basin where such allergy is considered endemic. These molecules are highly conserved and involved in plant defense against fungi and bacteria, and have a stable and compact tertiary conformational structure containing 4 alpha helices and 4 disulfide bonds that confers an extreme resistance to gastrointestinal digestion and thermal processing. And given such characteristics, lipid transfer protein are associated with severe adverse reaction to food, even after physical exercise. There are 2 distinct subfamilies of lipid transfer protein, but most of known allergenic LTPs belong to the first subfamily at higher molecular weight. 54 out of the 58 molecules currently registered in the IUIS database. Such molecules are cross-reactive, with the exception of the 2 lipid transfer proteins found in the pellitory of the wall pollen, PARG1 and PARG2, which have less than 20% of identity if compared to the prototypical lipid transfer protein, PP3 from peach. Okay, you know that in biology, homology is a qualitative characteristic of 2 species that are similar because of a common ancestor. And on the other hand, sequence identity is a quantitative characteristic represented by the fraction, the amount, the percentage of amino acids that are the same when you compare 2 distinct amino acid sequences. And this is relevant because within a given group of homologous molecules, for example, LTP, PR10, profilin, or seed storage proteins, allergens, a cross-reactivity is rarely found when you have less than 50% of identity. And on the other hand, highly probable when you have more than 70% of identity. And the sequence identity follows the rule of a botanical taxonomical relationship among molecules. In fact, if you compare the archetypal lipid transfer protein, PP3 from peach, to all the other lipid transfer protein reported in this rather chart, where the red line indicates the 70% of identity, you can easily see that in the vast majority of cases, the sequence identity is below 70%. Therefore, they are not cross-reactive molecules, with the exception of those sources that are related from a botanical point of view to peach, for example, European plum, sweet cherry, apricot, apple, and so on and so forth. Therefore, lipid transfer protein are homologous molecules, but they are not identical. There are 3 distinct IgE binding epitopes placed on the surface of lipid transfer protein, and here listed in this series of lipid transfer protein, where PP3 from peach is considered, as I already told you, the most reliable molecule to detect the maximum amount of patients having LTP reactivity. And in fact, when we studied 568 patients with LTP reactivity, Prupitri was the top-ranked molecule, detecting 81% of patients, but not the entire set of patients. And furthermore, when we evaluated the reciprocal relationship among these 7 molecules studied in the matter of IgE co-recognition, a significant relationship could be observed after bivariate analysis, only in few cases, those botanically related. At the moment, there are 17 different LTPs that can be evaluated with the more recent in vitro macrolide system. And when we studied such molecules in another group of patients, 332 patients, once again, Prupitri from peach was the top-ranked molecule, found in 77% of cases, followed by maize and apple LTPs, and focusing the attention on Prupitri reactors, comparing the prevalence of IgE recognition depicted in orange to the sequence identity of the different LTP in comparison to Prupitri. As you can see, these measurements were more or less in agreement in some cases, but there is an heterogeneity in molecular recognition, molecular detection at single patient level, and this underlines the added value of testing more and more molecules at the same time in the same patient to better define every single individual reactivities, also impacting on clinical outcome of patients.
Dr. Scala, there's a request if you could speak a little louder.
Sorry?
They can't hear you. If you
Okay, you cannot hear me? Okay, sorry. LTP allergy is endemic in Mediterranean area. But in the last 20 years, more and more studies, more and more evaluation, more and more detection demonstrated that lipid transfer protein allergy is worldwide spread. Also raising interesting issues regarding the heterogeneity of clinical expression of this disease that might range from no symptoms at all to very severe adverse reaction, and also controversy of a primary sensitization. And talking about primary sensitization, I'd like to show you several considerations drawn from this paper we published some years ago, comparing a group of Italian patients LTP allergic because of, in the majority of cases, peach sensitization, to a group of 35 native United Kingdom subjects with LTP allergy because of totally different sources of sensitization. And surprisingly, the IgE detection profile in the two subsets of patients were almost identical. Prupitri from peach being the molecule most frequently detected. And this observation indicated that when a given molecule is the most frequently detected in a given population, this not always means that that molecule is the primary sensitizer, but just the molecule that functions better than other in that given in vitro system to detect patients. Interestingly, this paper published no more than 1 month ago, a couple of days before I had to put my presentation into the system, two distinct populations were studied from US and Spain in the matter of IgE detection profiles, and despite a similar IgE binding profile to linear peptides of peanut, walnut, and peach LTPs, only patients from Spain could detect in a reliable way intact LTPs, conformational epitopes of LTP. And this might indicate why LTP-based allergy is so rare, is so uncommonly found in the United States. What is for certain true is that the tolerance rate observed in Northern European countries is significantly higher if compared to Italy or to Mediterranean area, ranging from 35 to 59% of cases, probably because of the concomitant sensitization to BET1 to PR10 molecules. And another interesting issue has been raised about the possibility that other uncommon, unconventional route of sensitization might happen, so, especially in Northwestern European country. In fact, In this paper, it has been suggested that LTP sensitization may be initiated by inhalation, contact, exposure to the LTP kinase 3 from cannabis sativa, from Indian hemp, even via passive smoke, and even in pediatric population. But once again, when a group of patients from the United States were studied for cannabis sativa reactivity, in no cases LTP reactivity was found, despite a couple of patients reactive to cannabis sativa root extracts. Therefore, once again, different population, different haplotype, different way of recognizing molecules, probably due to different dietary habits. And another interesting model is represented by Northern China. In Northern China, mugwort allergy is spread. You know, the mugwort pollen contains a lipid transfer protein, RV3, and the authors of this paper demonstrated that lipid transfer protein in that condition can behave exactly like the other pollen fruit syndrome, mugwort being the main sensitizer factor, followed by food allergy. And in fact, RV3 could totally inhibit proprietary signal in these patients. But the same experiment replicated in Spain, involving different part of the country, even non-Mediterranean area, where both mugwort and plant tree pollen allergy are spread. You know that also plant tree pollen contains a second relevant lipid transfer protein, PLI3. Okay, neither mugwort nor plant tree could inhibit proprietary signal, and therefore the authors concluded that in Spain, proprietary has a central role in determining sensitization to LTP, as well as in Italy, where in this study we retrospectively evaluated 1,500 patients, and also in our case, neither RV3 nor PLI3 could be indicated as the main sensitizer. But there are other interesting models. For example, olive pollen allergy. In this study, we evaluated about 800 patients. You know that olive tree pollen is spread in central and southern Italy. And as you can imagine, olive tree pollen contains another LTP, OLA7. But also in this case, OLA7 was associated to reaction to food and not to respiratory symptoms, as well as described for PLI3 and plant tree pollen allergy. And what about the United States? In this paper, peanut allergy was evaluated from a molecular point of view, comparing 3 distinct populations from Spain, Sweden, and US. And as expected, peanut reactivity was dominated by LTP allergy in Spain, 60% of cases, PR10 molecules, RH8 from peanut in Swedish population, whilst in the case of US patients, the vast majority of patients react to seed storage protein, 2S-albumin, 7S-globulin, 11S-globulin, and LTP reactivity was rarely found in less than 8% of cases. And similarly, in this other paper, performed across the United States, involving several centers from West, Midwest, South, and Northeast, and as you can see, LTP reactivity was observed among 14 to 18% of cases. But interestingly, because adults are not big kids, LTP reactivity in population having more than 40 years of age was the second most frequent cause of peanut allergy in the adult subset of patients. And if you are asking what happened in Italy, here the profile of Italian patients, we have to collect patients from 25 different centers because peanut allergy is so rare in Italy. And the IG sensitization profile was the opposite to what observed in US. 77% of patients having LTP reactivity, 21% of patients with 2S-albumin reactivity. And interestingly, a large group of patients, 35-40% of patients had reactivity to PR10, profilin, or both. And this is important, this is relevant, because we and others could demonstrate that co-sensitization to PR10 or profilin could mitigate the severity of symptoms of patients reactive to LTP or seed storage proteins. And in fact, I always suggest to my colleague to detect the presence or absence of for example, profilin reactivity, because this think could help in determining the subset of patients having lower risk to develop systemic reaction to food. Okay. And moving on from molecular profile to clinical symptoms, when you follow an LTP hypersensitive patient since the childhood, you can observe the presence of a sort of hierarchy of cross-reactivity. Ranging from one single food to multiple food detection, even botanically unrelated. And this process seems to follow a rather precise and specific and predictable route that starts in the vast majority of cases from peach, then is followed by other rosacea fruit, then peanut, and a number of other unrelated foods, cabbage, mustard, beer, vegetables, so on and so far. And these are the most dangerous patients, those able to detect more sources, more food, and in parallel, accordingly, more molecules. In fact, we already observed that the LTP detection profile in our patient is a little bit heterogeneous, ranging from one single molecule to multiple molecular detection. And those patients having the ability to detect more than 5 molecules were associated with higher risk to develop systemic reaction to food, especially if they were not allergic to PR10 or profilin, because such reactivity, as I already told you, could mitigate the symptoms and give just neuroallergy syndrome. And a possible explanation for such observation can be drawn by this cartoon. On the left part of the figure, you can see the ideal mastocytes from monosensitized patients, where all the Fcm receptor bear an IgE directed against LTP. Therefore, when these mastocytes encounter an LTP, you can have a mediator release even more efficient if compared to patients having multiple reactivities and multiple panallergen sensitization. And taking together all those considerations, we can try to depict a sort of diagnostic algorithm that can be useful in real life and daily clinical practice. So when you have patients having wide ability of detecting LTP molecules and monoreactivity to LTPs, you have the higher risk. On the other hand, low risk is associated with scant ability to detect LTPs and multiple panallergen detection. But you have to alert also those patients, because in the presence of several cofactors represented by physical exercise within 3 hours, the ingestion of food, or painkillers, anti-inflammatory drugs, or alcohol consumption in concomitance with sources containing LTPs, you can have, once again, high risk to develop systemic reaction to food. I have some take-home messages to share with you. First of all, LTPs are homologous molecules. They are not identical. Therefore, the more you test, the better it is. Secondly, different dietary habits, different geographical location might impact on prevalence and clinical outcome of our patients. If it's well asserted, it's sure that in the Mediterranean area, PUP3 is the main factor, is the central factor for determining the IgE sensitization to LTPs. We cannot deny the possibility that in other country, in other location, in other situation, lipid transfer protein may behave exactly like the other pollen-free syndrome, as reported in China with mugwort allergy. And also uncommon route of sensitization might happen, for example, the cannabis sativa, the Indian hemp in Belgium. And finally, there is an heterogeneity of clinical outcome of our patient, ranging from no symptoms at all to very severe reaction. And as a common rule, we might say that the broader the epitope recognition, the greater is the risk to develop systemic reaction to food. And the outcome of patients may be influenced by mitigating effect, like co-sensitization to PR10 and profilin, or enhancing effect, physical exercise, and anti-inflammatory drug ingestion in concomitance with LTP sources. And with this slide, I'd like to thank all my collaborators within my institute across Europe, and thank you very much for your so kind attention. And I'd like to dedicate my presentation to the memory of your client Tebe.